Lesson 4.2, finding slope from 2 points. So today we are working with the slope formula, which we are given right here. So we have m is equal to y2 minus y1 divided by x2 minus x1. We also talked today about how slope is often called rate of change. All right, let's go ahead and let's look at the first problem. We're supposed to find the slope given, or find the slope between these 2 points. Often on a test or something, when you're assessed over this, you'll be asked the question, what is the slope of the line that goes through the points 2, 3, and 9, 7? All right, let's check it out. We're going to go ahead and we're going to use this formula, okay? So I'm going to set mine up over here, m equals y2 minus y1 divided by x2 minus x1. And those letters might seem intimidating, so let's remember kind of just what they mean. And my points, since this is my first point, this is the x of the first point and the y of the first point. That's all that means, x1, y1. This is my second point, so that's x of the second point and y of the second point. So once you identify what everything is, you just plug it in. So let's see here, we've got m equals, all right, we've got y2 is 7, all right, minus, let's see here, y2 minus y1, which is 3. All right, so minus y1, right? Minus y1, we're using 3, divided by x2, which is 9, right? x2, we're using 9. And then we're subtracting, right, minus the last one here, which is 2. Right, x1 is the number 2. All right, thank you for being patient while I did my color coding there. All right, we've got m is equal to, all right, 7 minus 3 is 4. 9 minus 2 is 7. So my slope is 4 over 7. Easy as it gets, guys. You just got to remember that you have a formula for that and plug in your numbers. All right, let's look at the second one. 2, 2, and negative 1, 3. What's the slope between those 2 points? All right, let's remind ourselves of the formula. M equals y2 minus y1 over x2 minus x1. This is x and y from the first point. This is x and y from the second point. Not x and, sorry. All right, I'm not going to color code this time just to go faster. So y2 is 3. All right, y2 is 3 minus y1, which is 2, okay, all divided by x2, which is negative 1, minus x1, which is positive 2. All right, so in my case, m minus 2, we all know is 1, and negative 1 minus 2 is negative 3. And remember, if you're not sure, you type in your calculator just like that, negative 1 minus 2 is negative 3. Okay, so my slope, it doesn't necessarily mean just the 3 is negative, it just means that I have a negative slope, right? A negative 1/3 is my slope. Okay? All right, let's go ahead and let's look at problem number 3. Let's write the formula again. You cannot get enough practice with this. y2 minus y1 over x2 minus x1. All right, so we've got y2 is negative 1 minus the first y, which is 4. The second x was negative 5 minus the first x, which was negative 5. All right, negative 1 minus 4 is negative 5, and on the bottom we have negative 5 minus negative 5, which is 0. And if all those negatives confuse you, just use your calculator. Negative 5 minus negative 5, we're getting 0. Now, what is this number? Let's use our calculator again. What's negative 5 divided by 0? Uh-oh, it's giving us an error, right? It says error, divide by 0. Well, we're not allowed to do that. If this happens to you, you guys need to understand, right? You cannot have a 0 for a denominator, which makes this an undefined slope. All right, so you get an error in your calculator when you try and type it in. It's an undefined slope. Now, if you were really truly stuck, take 2 seconds and graph these points, right? The point negative 5, 4, just going to kind of estimate here. And then the point -5, -1, -5, -1. Okay, that makes sense that it's undefined, right? Because wouldn't these 2 points create a vertical line because they have the same x value? There you go. Right now, the undefined slope makes a little bit more sense. And last but not least, let's go ahead and let's look at problem 4. All right, in problem 4, let's go ahead and let's write out our formula one more time. We've got m equals y2 minus y1 divided by x2 minus x1. All right, so the second y is 3 minus the first y, which is 3. The second x is 8 minus the first x, which is -2. So this is going to give us 0 divided by x minus -2, which is 10. Again, you can always just double check if you're not sure with those negatives, right? 8 minus -2, and we do see that it is 10. All right, now again, we got a 0 happening, so we're like a little uncomfortable here. What's my slope of this? Check your calculator. What's 0 divided by 10? Well, that's just 0, right? That's just 0. So we're going to make sure that we just write out the slope is 0. Okay, we can have a 0 slope. And again, if you're not really sure what it's supposed to be, take 2 seconds and just graph those points. All right, -2, 3 would be about here. 8, 3 would be, I don't know, maybe over here. Okay, you see that would be a horizontal line. Makes sense for your slope to be 0. Last 2 problems on the notes today, we're actually starting to deal with word problems. There are a couple of key ideas here, and that is to understand what they're going to say when they're asking you about the slope in a word problem, because they don't say the word slope. In this problem, they say average rate of change. Average rate of change. So we need to understand that when they're talking about average rate of change, they're really talking about slope. All right, they're really talking about slope. In fact, if you see the word rate, that is a really, really strong indicator that we're talking about slope in a problem. Okay? The reason I want you guys to understand that we're talking about slope is because I hope that when you think of slope, you think of change in y over change in x. Right? I hope that that's what you think about when you think about slope. So we're comparing the change in something. So let's read the problem. Population of Austin in 1990 was 472,000 people. The population in 1980 was 346,000 people. So we're supposed to find the rate of change for this population. What we really definitely need to understand is that when we're done, we're going to have a rate. Okay? I want you guys to kind of keep this in mind. So we're talking about people per year. That would be the rate of change, right? People per year. Not year per people. That doesn't make sense, right? People per year. So since people's on the top, or since people is the first thing we read, right, that goes on the top, people per year, right? X is our independent variable on the bottom for time, and Y is our dependent variable on the top. We're using people. So what's the change in people? The change in Y, the change in people? Well, if they're telling us 472,000 is the first number for people, then they tell us 346,000 people. Do you see how I'm subtracting? Because I want to find the difference in the number of people, right? I want to find the difference in the number of people. And on the bottom, the difference in the time. Just make sure they line up, right? 472,000 went with 1990, and 346,000 went with 1980. Don't mix those up, all right? And we're going to subtract these, and we're going to get, let's see, 472,000 minus 346,000 is giving us 126,000 people over 1990 minus 1980, which is 10. We always want to simplify if we can, so let's try dividing 126,000 by 10, and we get 12,600. All right, now remember we said people per year. We need to actually make sure that we write that in our answer. So 12,600 people per year. All right, and that right there is our final answer for this problem. It's not complete unless you write people per year. That's not optional. Okay, last but not least, here we go. The value of my new car after 2 years was $11,200. When the car was 6 years old, the value dropped to $6,100. What is the depreciation rate for my car? All right, I need you guys to definitely focus on, home in on, realize that when they say rate, they're talking about slope, right? Rate, they're talking about slope. And we know that slope is the change in y over the change in x. All right, so in this case, would we say about the depreciation rate, would we say dollars per year or year per dollars? Hopefully we know that it's going to be dollars per year. I would say 90% of the time, guys, almost always year goes on the bottom, right? Time is almost always your independent variable, depending on the problem, but almost always. All right, here we go. We need to find the change in y. In other words, the change in the dollars. So we're going to subtract 11,200 minus 6,100. All right, and then the change in the time, right? 1,100 was when it was 2 years old. 6,100 was when it was 6 years old. And remember that we are subtracting these two. All right. So we subtract the top, 11,200 minus 6,100, and we get 5,100. And in the denominator, 2 minus 6 is negative 4. All right, let's clean it up. Figure out what we get when we divide. All right, we get negative 1,275. Now stop and think for a second. Does it make sense to have a negative number in real life? Well, yeah, because this problem's talking about depreciation, right? The car is losing value. So the rate is negative there. So we're going to say $1,275 per year. And that's our answer. All right. Remember, when you're dealing with slope in a word problem, you're looking for words like rate or per or each or every, right? And remember that when you're doing from 2 points, when you get slope from 2 points, you have a formula to use, or you can graph the points, or you can make a table for the points, whatever you want to do. There's lots of different ways you can find it. Good luck.